Hey guys, welcome back to another video. In this video, we will talk about MongoDB architecture and how sharding is implemented by MongoDB. Okay, so before we dive into the topic, let's first recall scalability. If you're not aware of scalability or if you have not watched the previous video, I'll highly recommend you to watch that first. I'll paste the link in the description. Okay, we know scalability are of two types, vertical and scaling. In vertical scaling, we simply add more resources to the existing server to handle more load. But in horizontal scaling, we add more instances. Now, if you think horizontal scaling can be implemented in two ways. Let's say you have total of 10 GB data, your application data. Now, first way is for each of the devices, you give the complete 10 GB of data. So that way, whenever any request comes, it can be forwarded to any of the devices by the load balancer. But the downside is that will be expensive, right? Each device will have to maintain that much, will have to keep that much storage to handle the data. And in future, let's say that 10 GB becomes 1 terabyte. Now, each of the devices will have to store 1 terabyte of data. What's the alternative? The other option is you divide the 10 GB of data between the number of devices you have available. So here, let's say we have a total of 8 devices, and currently you have 10 GBs of data. Now, you divide the 10 GB data between these 8 devices, and this is what we call as sharding. So let's take a deeper dive into that. So sharding by definition is a technique that is used to distribute data across multiple servers or shards. So these servers where you divide the data between can also be referred to as shards. Take example of this pizza. So here in this image, if you see, each of the pizza slice has a different topping, right? Now suppose each of these slice as a shard. Whenever a request comes, it has to be forwarded to any specific shard. Now, if you think the same data is not available with all of the devices, right? So now whenever a request comes, it has to be forwarded to a specific shard. We'll talk about this, how MongoDB implements this in the next slide. Okay. So with this single image, you can understand the complete MongoDB architecture. So I request you to watch this image and listen to the audio very carefully. Okay. So here we have our application server. So whenever your database tries to call MongoDB, this is where the request is hit. Okay. And this mongos. So this is a process which is responsible for distributing the data amongst the multiple replica sets that we have here. So here in this image, you see we have 3 replica sets: primary, primary, primary. So these are the 3 primary servers, and each primary servers in turn have 4 secondary servers attached with them. So how does it work? And here we also have this config server. So how does it work? Now, whenever any request comes, so this mongos process decides where it wants to forward that request to this one, or this one. Now, based on what information it will do that. So in this case, let's take example of users. Now we have user IDs, right? We need to have any unique ID in our database, right? So let's say we have our unique ID as user, and this user ID is also present in almost all the requests. So whenever a request comes which has ID from 1 to 1000, it will be forwarded to this one. Another request comes from 1000 to 5000 to this one, and similarly, if any request comes which has user ID above 5000, that request will be forwarded to this one. Now this Mongo's process, it needs to know, right, what is the key and on what basis it has to forward that request. So that data is stored in this config server, and we can add that data. It's not that MongoDB automatically selects that. That is configurable. We have to select what is the unique key on which we want to do the sharding. Okay. So how does it work? Let's say a request came. Mongo's forwarded that request to this primary server. Now this primary server decides these 3 primary servers are the shards, and all the secondary servers which are attached to this primary server are replicas of each other. So all the 4 secondary servers contain the same data. So this primary server decides on which server it wants to get the request from. So it can use any of those. Now, if you see from the image, we do have replicas here, like data replicas here, but you might think primary server here are a single point of failure. That's not the case. I'll tell you how. So whenever any of these nodes go down, the secondary server can take a vote and automatically set up a new primary server automatically. So you don't have to do any manual configuration. There is no manual intervention required. So automatically these secondary servers set up a new primary server in case of any of these primary server goes down. So we are secure. We don't have to worry of any data loss or any shard being unavailable. We have that covered. And similarly with config server. So we also have multiple instances of config servers. In any of the configs, in any case, any of the config server goes down, the config servers take a vote and set up a new server through which this Mongos can interact. Now, the only condition for that is you need to have at least 3 servers, because let's say this one, the last one goes down, there should be at least 2 present, right, to take a vote. So that's the only condition, to have at least 3 servers. Okay, I hope you got a better understanding. Just to make things clear, I'll quickly recall. You have Mongos. The Mongos is a process which decides where to forward the request. And you have 3 shards here: primary, primary, primary. So now if you recall, shards are something where data is not replicated. Each of these 3 primary shards contain different data. And based on the user ID, the request is forwarded to that shard. Okay. Let's say that the user ID was 1200. So Mongoose decided to forward that request to this primary shard. Now this primary server, it wants to fetch the data. So it is connected with 4 different secondary servers. It will decide, it can randomly pick up the data on whatever algorithm you want to follow. It will randomly pick up the data from a secondary server and then send back the response. So these secondary servers contain the replicas. So all these 4 servers have the same data. In this case also, all 4 have the same, and in this case also, all 4 have the same data. So here, if you see, we have sharding also implemented, and we have replica also implemented, right? So that's an amazing way of making the service highly resilient and highly available. Okay, so let's move back to next slide. Move to next slide. So you might have a question: what is the difference between replication and sharding? So let's go back and take a look at our pizza again. For this image, consider this pizza, and each of these slices are these 3 primary servers. So first slice is this, second slice is this, and third slice is this. Now, what these secondary servers are? All these servers contain the same data. So slice one with this one, slice one, slice one, slice one. When we come to this one, slice two, slice two, slice two, slice two, and similarly for this one, slice three, slice three, slice three, and slice three. So here we are replicating the data, and here we are sharding the data. So that's what is the difference between sharding and replication. So if you want to take a look at the definition, the primary server node copies data onto secondary server nodes. This can help increase data availability and act as a backup in case of the primary server fails. And also, as we spoke earlier, the secondary server decides, like in case of any primary server failure, the secondary server vote amongst themselves and they select a new primary server. What is sharding? How is sharding here implemented? So sharding handles horizontal scaling across servers using a shard key. So this means that rather than copying the data holistically, sharding copies pieces of the data across multiple replica sets. Exactly what we discussed earlier. So I hope you now have a better understanding. This was all as part of this video. Hope you learned something new. Thanks for watching.